So with chapter 3.6, we are right back to inequalities again, and no, I can't tell you why we took a sidetrack into set notation. But anyway, your first vocabulary word for this section is a compound inequality, which means two inequalities that are connected by the word and or the word or. Your other vocabulary word is interval notation, which is basically a notation that uses those symbols, and I'm not even going to try to explain it until we get to problem 5 because it's kind of hairy. So take a look at problem 1 on the top of page 201. Here are a couple of examples of compound inequalities. Letter A, all real numbers that are greater than -2 and less than 6. So here it is written out in math with the and here it is written out without any English at all, and here it is graphed. So all numbers that are greater than -2 and less than 6. Here's an example using an or. All real numbers that are less than 0 or greater than or equal to 5. T is less than 0 or T is greater than or equal to 5. You can't write this as one smooth inequality because it's not, as you can see, it's not a smooth continuous group of numbers. There's one group of numbers off that way, there's a different group of numbers off that way on your number line. Try this a couple times. Got it? Number 1. You need to write a compound inequality for A and graph it. You need to write a compound inequality for B and graph it. And then you need to think about letter C. I'm going to go get my next cup of tea. So I think problem 1 is the type of problem that sounds really complicated, but in fact is pretty simple. They gave you all real numbers that are greater than or equal to -4 and less than 6. And when you translate that into math, look at how straightforward that is. X is greater than or equal to -4 and X is less than 6, which you can combine into this. -4 is less than or equal to X, less than 6. That's it. A graph will look like this. Open-ended circle here, closed-end circle here, because that's greater than or equal to. Now let's move over to letter B. It's not an and, like I tried, it's an or. X is less than or equal to 2.5, or X is greater than 6. You can't do anything else to combine those because we have no math symbol for or. And so your graph is going to have two distinct sections on it. One to show that X is less than or equal to 2.5, and another to show that X is greater than 6. So for letter C, I said just think about it. The question was, what's the difference between X is between -5 and 7 and X is between -5 and 7 inclusive? Well, that's a question of, do you know what the word inclusive means? And the word inclusive means including. So the difference would be one includes -5 and 7 and the other one doesn't. And again, yeah, it's just that simple. So now that you know what a compound inequality is and you've had some practice writing them, let's take a closer look at the ones that use and. If you're trying to figure out the solutions of this inequality, what they want you to know is you can break this up into two inequalities and solve each one. -3 is less than or equal to m minus 4. Solve it, you end up with 1 is less than or equal to m. On the other side, you repeat the m minus 4. M minus 4 is less than -1. Work through the solution. M is less than 3. Now combine it again. 1 is less than or equal to m is less than 3. And there's your graph. Try it on your own with got it number 2. I'm going to drink some more tea. So here's the compound inequality they gave us, and I'm going to break it into two parts to solve it. -2 is less than 3y minus 4, and 3y minus 4 is less than 14. I'll start with this side. 2 is less than 3y, divide by 3. 2/3 is less than y. Then I'll come back over here. 3y is less than 18, divide by 3, y is less than 6. Then when I bring them both back together, 2/3 is less than y is less than 6. There's my graph. I goofed up the spacing a little bit to try and show 2/3. Next, if this way makes sense to you and you're very comfortable with it and you don't want to mess with it, that's fine for me. If you are the person saying, but wait a minute, do I have to separate these in order to work on them? Then you need to go on and do problem 3. So here's problem 3. They set you up with this whole test inequality thing. And they're going to show you that you can work on the whole thing simultaneously. But you must remember that whatever you do to one section of this inequality, you have to do to all 3 sections of this inequality. So they're multiplying by 4 here to clear this fraction, multiply this by 4, multiply that by 4. If you're going to subtract 251 in this step, subtract it here and here as well. So that's how you would work with it simultaneously. Got it, number 3. I knew so many people like this in college. They would take a look at what they had scored on their first tests and then figure out how well they had to do to get the grade they wanted on their last test. And, well, if you want to earn a B in the class, study enough to earn a B all along. It's just silly. Moving on. So with problem 4, and everybody's following this one carefully again. With problem 4, we are working on, obviously, compound inequalities involving OR. You have to solve these as 2 halves. And they show you how. And then they show you how to graph it. The ones that have OR, those are the ones that have this space in the middle. Got it, number 4. What are the solutions of this inequality? And graph it. So write those in your notebook, solve each side, and then graph what you get. Let's check in a minute, make sure we all match. So here's what you should have written in your book. Problem 4, both inequalities, and we're going to start with one at a time. So negative 2y less than negative 6, divide by negative 2, and I did not forget this time, flip the inequality sign. Y is greater than 3. Now come back to the top on this side. 4y is less than or equal to negative 8, divide by 4, y is less than or equal to negative 2. So here's your simplified compound inequality. Y is greater than 3, or y is less than or equal to negative 2. And here it is on a graph. Y is greater than 3, or y is less than or equal to negative 2. So I'm going to be frank with this last page, page 203. I don't like it. We're going to go through it because it's here in the book, but don't get too worked up if it makes no sense to you. They're showing you another notation, and it's called interval notation. And basically, you're going to use either parentheses or brackets. Parentheses when it's not equal to, greater than, less than, or equal to. Brackets when it is greater than, less than, or equal to. This is a little infinity symbol, or a negative infinity, to show that the graph is moving off forever in that direction. Basically, if you take this nice, straightforward, comfortable inequality, x is greater than or equal to 2, here's what they turn it into. They use a bracket on this side because 2 is included, comma, infinity, because it goes off towards infinity, and then a parenthesis here. Try this one. X is less than 2, does not have the less than or equal sign. Here's your graph. This time we have a parenthesis, negative infinity, comma 2, parenthesis. 2 is not included. Notice that in both of these examples we start from the small number on the left and move to the big number on the right. Same thing here, small number on the left, big number on the right. Take a look at this one. 1 is less than x is less than or equal to 5. So we need a parenthesis on this side because 1 is not included. The smaller number 1, comma, 5, and a bracket because 5 is included. Last, we have a compound inequality involving an OR. X is less than negative 3, or x is greater than or equal to 4. So we're going to start with the smallest, here's the graph, then we're going to start with the smallest number, negative infinity, parenthesis negative infinity, comma, 3, parenthesis, or 4 is included, so we have a bracket, 4, comma, infinity, parenthesis. Take a look at that. Now they want you to practice using it on problem 5. They give you the graph of this, and they want you to be able to translate it into an inequality. They give you the inequality here. They go through a similar problem with letter B. Give got it number 5 a try. Like I said, I'm not going to worry about it if it, well, where's the right face? Okay, if this is making your hair stand on end, I'm not going to worry about it. But give it a try. It is just another way to say something that you already know how to say. Alright, so you probably don't need to copy my editorial comments into your notebook, but I did put this in, and this will probably help you. Parenthesis means it's not included. A bracket means it is included. Here was my first try to write what they gave. I put down -2 is less than 7, but that actually is an incomplete answer. What that interval notation really means is -2 is less than x is less than or equal to 7. Now that I've got that, it's not so hard to graph. And letter B, y is greater than 7, open circle there, off towards infinity, and then here's how you write this in interval notation. The smaller number on the left, parenthesis because it's not included, and then the bigger number on the right. Nothing's bigger than infinity. Whew, we made it. So to finish this up, the lesson check on page 204, but I'm giving you some more complicated directions. Number 4 has 2 steps. They want you to write the interval as an inequality and using interval notation. So I want you to give number 4 2 points. If you can write it in interval notation, that's going to be a bonus point. Number 6 is also a bonus question because that's interval notation. And number 7, kind of like number 4, split it into 2 points. 1 point for just writing it as an inequality, a second point, a bonus point, if you can write it as interval notation.